Hello, hello guys, hello friends. We have an amazing night today. Yesterday, I'm asleep till 4 a.m. We have an experienced musician session here in Tallinn, live session, guitar, and I'm asleep till 4 a.m. So I'm a little bit tired and my voice is a little bit creepy, but I'm happy to see you here. The main goal of this topic is to speak about the logging, monitoring, and related things. It's not a technical presentation. It's presentation in the way of thinking. So can you imagine, can you think? And I describe some points of view. So my points of view, my colleagues' points of view. Okay, I live in Tallinn, Estonia. And before them, from the beginning, I burned in Siberia, living in 6 years in Siberia. After that, I lived in Anapa, it's a Black Sea coast for 10 years. After this, I lived in Moscow for 10 years, and now it's my 5th year in Tallinn, Estonia. We have IT experienced professionals in Tallinn, and I welcome you to Tallinn. It's a great city. It's like a Riga. Okay, let's start. The main topic is about the rocket science. It's mostly a joke, but we have some examples, and it's near the rocket science. Okay. All of us, we have monitoring logs, some trace, some data, and all of us deliver, store, and analyze these data. So we speak about how does the monitor and monitoring information and log information improve our technicians, improve our business processes, and make us happier. So the first sentence is about the metrics. In IT monitoring, we have the word monitoring. What does it mean? I think it means some kinds of methods using to collect data, to collect some metrics using external checks. These checks are mostly synthetic. Synthetic means it's made up by you. So it's scripts, it's like a traps, it's a periodical flows information. So it's not real-based flows informations. When we speak about monitoring, we speak about some kinds of protocols, agents, data descriptions, and some kinds of storages. Storages, we can use a notify model, so notifications. It's mostly reactive procedure. Who knows what the classical monitoring metrics here? By metrics, I mean the nature of the data. So what the data? Do you know? In monitoring solutions, we use numbers. So numbers, it's a strictly powerful way to compare the data. So numbers, integer, booleans, and etc. There are many monitoring interfaces, and the Zabbix is a more powerful. Yeah, we know about this. It's this Zabbix conference. It's a graph from our production systems. We also use Zabbixes. We have I think it's 4 Zabbix services in our client's infrastructure, in our infrastructures. Zabbix is best. What's the main purpose of monitoring data? So all of us use dashboards, special dashboards that collect informations, and from the technician point of view, present this information to our technicians, to our IT support, IT help desk, and it's a superb feature of the Zabbix. All of us use notification systems, using SMS messages, using mails, using some other traps such as Jabez and etc. Skypes. There are integration scripts with Skype, yeah, also, you know. Also, we use these types of monitoring solutions to visualize data. Because of data, you have 1 million integers. It's nothing, yeah? All of you need is to visualize the data, to compare the data one set to another set. So it's about visualization. Some of you use Zabbix as IT inventory. So you create some hosts, some descriptions. So this server located here, consists of such type of servers. You may using as macroses. Okay. So in brief, when we speak about the monitoring in brief, we can talk about SIEM-based. What does it mean? Databases used fields, tables. In Zabbix, there are abstraction from the database storage here, and we all used I don't know exactly now names of tables. So it's a SIEM-based storages. Okay, when we speak about monitoring, we use the words protocols or agents. We use special agents or special protocols. Protocols such as SNMP traps, SNMP active checks, SNMP passive checks, or special agents. It's consists of Zabbix agents or other written by you. Stored data is not reusable. Let me introduce this sentence later. All of you understand that this monitoring data is needed by IT technicians and admins. By admins, I mean the operationals from the business point of view. Magical gesture? Oh, yeah. What does mean logging? By logging, all of us means only syslog logging. So it's common way of thinking. So I think that logging is some methods used to collect the flows, but not the flows, but data, information of the path-through flows. So we have a black box and some flows going through the black box. And after this, you give some information about the IP addresses, about the statuses, about the other kinds of information going through this black box. So it's about programs, transports, syslogs, and etc. So it's mainly proactive. Proactive means that you have a black box, you have a real flows, real data flows. It's not a synthetic checks. It's data provided by your users, your flows. So it's real data. What are the classical log metrics? Most of us thinking it's strings. So we store the strings, and it's a huge amount of strings. So 100 symbols to 1,000 symbols, and etc. There are some logs called traces. Traces means you have a 1,000 of kilobytes of these logs. It's not a logs, it's only a trace. Some common classical log analyzer interfaces. It's log analyzer by Risco, and it's a Graylog. So all of us, I understand that logging is a much harder to understand, and I think the Graylog, who are using Graylog here? Maybe, okay. Who are using other tools? Oh, okay. What the main purpose of logging? So the mainly is all about the resolving problems. It's all about the debugging, development. It's all about the developers and their codes. From the technical point of view, we need a huge amount of storages for log storage. Why? Because we have a service generated about 10 gigabytes per day of logs here, and we have 300 of this service. So it's a huge amount of data. It's about 5 terabytes per month, like this, or maybe more. So it's a huge amount of logs. Many of you have using logs for security access violation event storage. So all of us have a network specialized device, yeah, and where NB comes to us and asks, give me the IP address of this hacker. Yeah, we use these logs to provide these informations. So it's a business critical information and security related information. We need to store these logs for a month, years. We have a special European Union directives. We store these logs for 8 years, 8 or 9 years. So it's a really huge amount of data if we store it 4 years. So in a brief, logging is mainly seamless. So what does it mean? You haven't any template, you haven't any prepared template for these logs. Logs is untemplatable in common, yeah? We have AP or REST interfaces, or maybe common syslog. The main sentence is the stored data are reusable. So this sentence we'll speak about later. All of us, you know, we have a special logs called trace. Who develop software by technicians or by self-developers? So, okay, Right, so many developers here. Do you use a logging in your products? Of course. What type of logging do you use? Maybe console logs, maybe some traces here in files.
Well, in Zabbix we use both the separate log for the Zabbix server and the standard PHP log in front.
Standard PHP log, okay. Let's imagine you have a standard PHP log and you have a PHP traces. It's all about one trace of 200 kilobytes, yeah? We can imagine this. And we have these traces 1 per minute. It's like a cron jobs or like other jobs, yeah? They have a huge amount of unstructured information. So how you pass it today? Visualize, yeah? You open the log, yeah? You see there, this string is bug, this string is bug. But it's a huge amount of data, a really huge amount of data. So when we speak about logs, the mainly is used by developers. The main question of this presentation, of this topic, is do the data in monitoring is the same as data in logging? I think yes. I think yes because the nature of these 2 points of view is they equal. So yes, if we have a well-tokenized and well-structured data, it means that we have a key like A and the value like 2. We have a key like 2 and the value like me at email address. So it's a token-based, yeah? All of us know the token-based formation. When we speak about token-based formation, we speak about the layer of delivery. So it's about JSON structures, it's about CSV structures, it's about the XML. So it's a structure dependent to the transport layer, yeah? Next step, we have a mapping here. Mapping means, I think the element A is an integer, so it's a countable value. Right? But what's about the 2? The value 2 is array, maybe an array, maybe string, maybe other kind of data. So we can have a mapping. Storage layer must have possibilities to automatically tokenize these values. So, for example, I have a value shown in left side. There are 1, 2, 3, 4. I like 5 tokens here. Always here. It's me, it's at, z, point, and com. So it's a tokenizable procedure. The next sentence is about how we get the data from the storages. Let's assume we have a field. Some fields, I know, 100 fields, or maybe even more. And I know that the fields called to have information that I need for. Okay. And I need information that consists of the value A and the value com, or the value Z. It's a common syntax of expressions from these engines, from these storage engines. Let's speak about the nature of these data. So monitoring and loggings are a subset of events. I think so. It's my point of view. Yeah. The main difference is the monitoring is mainly reactive. Reactive, it's not an operational state. Reactive means you use not really production data. You use external checks. Checks, it's not a really productive information. It's only synthetic information, yeah? But logging, it's mainly about the flows, really about the production flows you have. What does mean the events, as I think of? Is a set of possible types of messages. All messages we can call the events. So I think that monitoring and logging are the subsets of events, and we must understand that we stored only events, not monitoring data, not integers, not strings. We stored the events. Let's speak about the engines and log-driven monitoring itself. What does it mean, log-driven monitoring? So it's a sum of techniques provide access to events, not events, but fields in events. We have tokenized fields, yeah, here. We have a high-level decision-making application. It means that we may use a Zabbix server, we may use Nangio server. So it's not a task what the kind of server do we have exact. It's about the way of thinking. So we have a high application, high decision application maker. And from the point of view, from this application decision maker, we have some kinds of logs. Logs here monitoring, so events, subset of events. And log-driven monitoring is about how we access to the data, how we store the data here, and how we made some actions. So it's notifications, it's triggers, so it's about actions. Let's assume we have statuses here. Just a sec, okay. Statuses. We have a proxy status with an error code, yeah? And we have GMX status with the error code also. And we have about 1 million events like this. Can you imagine if we select these events by such type of query? So let's show you. Let's show me a proxy status, GMX status, but it's a wildcard status, yeah? So it's a not common query string from SQL point of view, yeah? Does anybody use some token-based storages? Redis, maybe, Elasticsearches? Okay, you understand this point, yeah? Okay. So from the developer's point of view, it's like an ordinary key value storages. And the action is notify. So some action, some notifications. So this is how I understand the log-driven monitoring. Let's speak about Zabbix. Thank you to Zabbix. We have LLD support, and it's really superb. So thank you, Zabbix, for LLD. It's a really killer feature. Really killer feature. So I have happiness in internal because after LLD, our work procedure is improved. So our business processes are made me happy. Okay. From the log-driven monitoring point of view, we have trappers. By Zabbix trapper, I mean not in active checks and not in passive checks. So it's not a Zabbix checks. It's only some element data that wait for data. And we have external tools to send this data to Zabbix servers. These posts created by JSON posts from external CMDB or from other engines, like, for example, Erlang Zabbix server, sender, sorry. We have written on the Erlang Zabbix sender, and it's really fast to slide, so really fast. It's like a C-based. I think in some procedures it's faster. We have a system-based service for it, so it's a production screenshots from our systems. But what's about the main goal of this topic? What's about data storing, the data and analyzing, and data access? Let's speak about the data. It's a Kibana interface from Elasticsearch engine, yeah? In this slide, we have 3 days. Okay, 3 days of mail logging. In the lower side, we have these graphs, but in the percentage view. So it's a 3 days view from the real MTA server. What purpose of this picture? The purpose of this picture is to show you well-structured graphs. So all of you can see, just a sec, how does it work? Yep. All of you see these metrics. So it's like ranges. And this ranges is dynamically written. I show you in live session here. It's a derivatives. It's a real-time derivatives made by Kibana, made by Elasticsearch engines, and made by Elasticsearch capabilities of the engines. So it's a really real-time data for the 3 days. What's about the transport of these logs? All of you know that there are maybe 3 or maybe 4 main products of syslog-based logs. It's rsyslog, it's what are the names? rsyslog, syslog-ng, yeah? Do you know the other names? Okay, let's 2 products, syslog-ng and rsyslog. So this is configuration of our custom rsyslog, and configuration based on the newer syntaxes made in the version 8. The version 8 is the mainstream version of rsyslog. So it consists of, let's show you here. This consists of JSON-like syntaxes. So we have some properties here, some just a sec, some variables here. So my host name here, Unix timestamp here. So it's a JSON-like configuration based on CE and JSON messages. Because of we use rsyslog in modern configuration, we can use tokenizing. We can use many powerful features such as delivering messages and such as let us show you. Okay. This is rule set. Many of you use the application from the Elasticsearch from the Kibana set called what is the name of these messages? You know? What is the name of this application? rsyslog, Kibana, and in the middle of Graylog, yeah? Logstash, yeah, Logstash. Okay, it's like a Logstash syntax of. So we have a host name and program name. So if program name is kernel and message contains this string, then we have an action like normalizing. So it's a tokenizing feature. And it's a tokenizing feature based on C code, not on Java code. It's much faster, it's pretty faster. And if we have no one pass data, we call Roger. Roger means send these logs out. Send these logs out to what? To some kinds of transports. Transport means TCP transports with queues, with real queues, with guarantees of the delivery of the messages. All of you use, I think, queues in your syslog products, and it's mainly a headache if you have your queue in disks, because of disk is slow, yeah, and in memory queues are much faster. Much faster is 100% faster, maybe more. But after shutdown and restart, this in-memory queue is lost. rsyslog have watermark queues, so it's a really cool feature. Linus Torvalds is not a great, he's not only a great developer, but he's a great speaker, a great person. And he said, "Talk is cheap, show me the code." So the main purpose of this presentation is not in technical, it's about the point of use, how we store and how we deliver data, how we deliver logs or how we deliver other data. Okay, I have an example sentence. After this, we have a live sessions here. So the upper graphs show you real spam filter graphs. We have a, let us show you accepted mails. It's about 2 kilo messages, and we retrieve this in 100 milliseconds. So it's really much faster than the current Zabbix. So it's not about Zabbix is slow, Zabbix is faster. It's about the way of thinking of the storing information, of retrieving information. Let us show you, show me all messages. It's about 2 million messages. Time to retrieve, it's a half a second. Yeah, it's really cool. If you ask Zabbix, please show me, please visualize this amount of data, how many minutes does Zabbix or Synapse? Minutes, no, 2 minutes, 3, or maybe more, okay. The other graphs I have, it's about 2 million subsets of HTTP logs, and it's HTTPS-based headers, yeah? So we use Cypress. It's a Cypher pie chart. And this is a HTTP statuses pie chart. We have 2 million of messages, and time to retrieve is 200 of milliseconds. So it's really fast. Another one sentence is about show me all syslog messages, unstructured syslog messages you have. It means that there are really huge strings. For example, 2 kilobytes or maybe 4 kilobytes or maybe even more. And it's about 4 million messages. Time to retrieve is about, it's more than 10 seconds. So it's really great. Let us show you how it works in live. I have 3 templates here. Let's start with the first. It's a pre-production service. Just a sec. Hop. Okay. I can show you the 7 days data in real time. So it's about 2 seconds here, and subset is half a million, slightly bit more, yeah? Half a million messages in 2 seconds. So it's a graph, it's a pie chart for this. It's rendered right now. Yep. So it is only problem messages. But what's about the overall messages? My Chrome is hanging up. Okay, overall messages, it's slightly like a 2 million, yeah? Slightly bit less. So it's 2 million messages right now in live session. In 2 seconds maybe 3, maybe 4. But it's seconds. Okay. What do you say? 20 million. Yeah, sure. 20 million. Oh, really? Okay, so this is Elasticsearch engine. And its engine have a possibilities to automatically tokenize the data, automatically store data with the tokenized procedures. And it's much faster than other methods of collecting data and storing data. Why I speak in Zabbix conference about this? Because of we have a logs and monitoring data, and these data are related to each other. Okay, let's assume why show this? We have a status, it's okay status, yeah? But when we speak about not okay statuses, I need a possibility to notify administrators. So it's not errors. Okay. It's a live session. It's about 5 minutes. Can you wait, please? So there are as many information as I need. So it's about connections, about concurrent connections, about milliseconds in queues, milliseconds of waiting in the back-end side, in the front-end side. So this unstructured log before Elasticsearch is a JSON-like. So it's all the fields. Okay, let's try another example. Let me retrieve the really unstructured data from the Elasticsearch from 2 days, starting from 2 days. Yep, it's rendered. So 7 seconds, not more, yeah? What's about the count of messages? Oh, no. I disable all the triggers I have. What's about counts? Can you count this one? 32 million. It's a real live session with 32 million messages in like a 7 or 10 seconds, yeah. Okay. But what's about the real purpose of these logs and monitoring? It's a 3rd-hour sessions. Yesterday, about 11 a.m., I have a mail from my colleague written by, we have some problems in our mail system. Some problems, I don't know what. Please get the feedbacks. So I use these dashboards to collect this information. I show you how. Let's start from the end of. So we have a problem information here. So right now we have a choose a smaller time scope. Just a sec. Now the subset it's a little big subset. So we have a huge amount of data because of these. I need to have a small sets. Pop. Okay. I think it's better. So this graph is really huge. Nope. Let's remove some fields here. Action, yep. I don't need action, I don't need I need message ID. I don't need to field. I don't need a rule field. Okay. Okay, let's see. So we have an MTA server, so mail transfer agent. And one of our clients told us that I received too much spam from your mail servers, from your mail systems. Please do something with my mail flows, because I have a so huge number of mails. We have a well-known spam filters. We have a strict spam filter technique, but there are some messages that come through the spam filter unconditionally. So this message is accepted with score, with such score. We assume that's just a sec. I will check Sender. It's another technique. So I don't want to show this filter. Okay. Accepted, accepted, accepted. So these messages, those have needs to have two logs strings. So before accept it, we need to accept it with gray log as accepted with other spam procedures. But this message is not related to other logs. So I assume that in this time I need another log message here. But this mail is really a problem because of this. Actually here. So please find the messages related to this, and I show only accepted. Yeah, only one log string. But what's about the other messages? Yep. It's all a live session, so it's a live production data. It's millions per minute. Just a sec. Yep. Our batch queues is deleted these messages today. As I saw. So I assume is deleted. Okay. The nature of this live session is to show you how we retrieve the millions messages in live in about 2 seconds, 4 seconds, so less than 10 seconds. The main purpose of my Zabbix presentation here, related to the Zabbix, is to tell you that a Zabbix is a system needs by technicians, needs by notifications, needs by technicians to notify, to make a dashboards, but not good for storing the data, storing the real data flows. Because of real data flows, you have such more information. So these logs, in 7 days, I think it's 200 gigabytes of these logs we stored. So 7 days, it's 200 gigabytes. The passing of these 200 gigabytes in text files or in Zabbix, it's too much time consuming from the server side, from the databases, and from the other search engines. So Elasticsearch is the best engine to visualize data, to search through such amounts of data. Okay, I think that's all. Thank you.
Thank you. Any questions?
Yep.
Thank you for your presentation. Have you found, for you, working useful way to, combine Elasticsearch together with Zabbix, so you can use the trigger mechanism out of Zabbix, so you can use, for example, Elasticsearch to, do searches on log files, etc., but to do the alerting stuff within Zabbix?
Yeah, I understand the question. So the matter of the question is how we use two subsystems here in one set. So technicians have their interfaces, their dashboards here, and we have other interfaces to this data. So we developed our product in Java, in Scala language, that have access to these data, to the Zabbix data, and it's like a CMDB product. So we create host, and this related to the logs by SSLog, and related to Zabbix creation of items and hosts. And after this, we have our own dashboards. All dashboards are our dashboards that conclude, not conclude, but summarize the information from the Zabbix by using API and from the Elasticsearch using this API. So it's only custom methods. Right now, it's dependent. It depends on what information do you need. So in Zabbix, we use the Zabbix information. In Elasticsearch, we use Elasticsearch information like logs. But in the middle of next year, we release our version of monitoring, of our logitoring. It's mean logitoring. Yeah, it's logs and monitoring, logitoring.
How you have overcome the stability issues of Elasticsearch?
What issues do you mean?
Because, well, it's not really production grade yet. We have seen a lot of memory leaks and crashes on the Elasticsearch.
Really?
Yeah, on the Java side, on the JVM.
This server, this JVM with Elasticsearch is up for 7 days, and memory leaks it's too smaller. So it's about 10 megabytes per day, like this. Maybe slightly more. But
so you haven't noticed any crashes?
Yeah, we haven't got any crashes.
Okay. And the second question is, as I understood, you are using syslog to deliver data to...
No syslog. Syslog is a common way of in-the-charge information. We use rsyslog. Rsyslog is an engine like
I understand.
Stage, yeah.
The question is how you are dealing with, for example, network outage, because then the logs are basically lost on rsyslog.
Logs is not lost. It's a queues. It's a queues. In memory queues, there are, after watermark in memory, there are these queues, that are stored, that's safely stored in restartings, in power outage. There are proxies. We have a logs proxies here. So location in L2 connections, we have mainly about 12 or maybe much more L2 locations. So in OC model, and we have a proxies here. So log proxy and L2 overconnect over the network.
So you're not worried about losing data, like
we test
data arriving in Elasticsearch.
Nope.
Due to some outages.
We test some kinds of methods to lose the data, but I haven't lost any data. So right now I speak in rsyslog forum. My list is about I lost one message. I don't know why, but I lost one message. One message per 1 billion, like this.
Yeah, but if you are dealing with financial data, then yeah, that's a lost transaction.
It's related to our connection with Elasticsearch. It's a bulk HTTP posts, yeah? And the problem is not in syslog deliveries. The problem is bulk HTTP imports to... So the problem is our configurations, mainly.
Okay, thank you.
Have you considered using Logstash for delivering data from syslog to the Elasticsearch? Because as from my experience, rsyslog is not flexible enough to do actual message modification and parsing. As with Logstash, you can do a lot more with data and strings.
What version of rsyslog do you use?
Sorry?
What version of rsyslog do you use?
Version
7, yeah?
7, something like.
You can use 8 version. 8 version it's much more faster and pretty much like a JSON configuration. So it's faster than Greylog. Yeah, Greylog. Not Greylog. Logstash.
Yeah.
I'm immediately. Okay, Logstash, it's a Java-based application. Right. If you try to deliver 1 billion messages, you can see the CPU consuming, yeah? And it's about 400 persons consuming. We test this. But what's about rsyslog? It's consuming about 30, 40 maybe persons of CPU. So it's much faster. It's more or less CPU consuming and small as memory consuming. It's a C code. It's an ordinary C code. And it's enough flexible, the 8th version.
Okay, thank you.
Okay.